Hello and welcome to ONUG Spring 2016. This proof of concept was created by Glue Networks to address a use case developed by the SDN Federation Working Group. Looking at this depiction of our present-day landscape, as defined in the white paper from the SDN Federation Working Group, shows our current progression to apply a control layer of software-defined networking to the infrastructure layer. SDN controllers are beginning to emerge, providing centralized control plane and other functions like network discovery. Orchestration functions are also becoming available, enabling centralized management functions for provisioning, configuration, and lifecycle management of the infrastructure layer components and network services. For this demonstration, Glue Network's orchestration platform called Gluware will be used to orchestrate a WAN SDN controller, in this case an application policy controller known as the Hub Master Controller. Gluware will also connect directly to the infrastructure components for configuration management. Both the controller and infrastructure components are provided by Cisco Systems. The SDN Federation Working Group has defined 4 use cases primarily related to how applications and services are managed across the network and data center infrastructures using the control layer made up of SDN controllers and orchestration platforms. This proof of concept is demonstrating use case number 1, which describes application resiliency between data centers. This use case describes applications running in data center A and dormant in data center B, and the network providing either automatic failover if the application fails or manual failover if a business decision is made to fail over. For automatic failover, this requires application monitoring. For manual failover, this requires the orchestration platform to reconfigure the environment. In this proof of concept, the WAN infrastructure is using SD-WAN technology, specifically the iWAN architecture from Cisco. This is made up of 2 head-ends providing connectivity to the primary and alternate data center and branch locations which are dual-homed with both an MPLS service and a broadband internet service. This provides redundancy and increased bandwidth while lowering cost over pure MPLS VPN services. iWAN architecture leverages DMVPN tunneling for connectivity. The iWAN architecture uses performance routing, or PFRv3, for application routing policy. This is implemented via configuration on a node called the Hub Master Controller, which pushes the policy to all the branches. This demonstration will showcase the orchestration platform performing an initial provisioning of the branch nodes, then continuing to show an update of the policy on the Hub Master Controller to add a policy for Office 365 and Facebook to the existing policy on the network. Gluware Control is a cloud-based software-as-a-service orchestration platform which uses secure SSH tunnels to connect to and configure the network infrastructure nodes. Now, using Gluware Control, we will provision 2 nodes. We have the Seattle node and the Sacramento node, and you can see these are currently not provisioned. Gluware Control breaks down configuration into many components, and these components can be grouped together into what's known as an assembly. Here we have an assembly for iWAN, and the drop-down panel shows how an IT operations engineer can configure the given variables. Now let's move back over to the node view and take a look at the 2 nodes that we have defined in the system. So to provision them, we'll select both nodes, move over to the action bar, and select these nodes to be provisioned. We click Start Provisioning, and Gluware will connect and apply the initial configuration or any updates to the nodes. This will take a few minutes since it will create a backup, read and analyze the existing configuration before making any changes. Now the provisioning is completed. We can see in the grid view it's showing provision for both of the CPE nodes. We can switch over to the log view and look at any details that transpired during the provisioning. For a manual verification, we can select a CPE and connect to it and issue CLI commands like show DMVPN to verify the tunnels are up to each of the head ends, and here we can see both tunnels are in the up state. Moving on to application control in the network, we're going to move on to configuring the performance routing. So in Gluware, we move over to the domain for PFRv3 and select a given instance that we already have configured. The current instance has a policy for video as well as voice. And you can see with voice, its preferred path is MPLS, and the backup is sending it over the internet path. Next, we're going to add a class for the application Office 365 using application mode to match the application. This is built into the Cisco feature set, NBAR. We're going to select Microsoft Office as a predefined application type, which will be low latency data, since we want the best performance for the Office 365 suite. Its preferred path will be the internet to leverage the high bandwidth, and it'll fall back to MPLS if there's a problem with the network. Next, we're going to add a class called Facebook, since we don't want Facebook congesting our MPLS circuit. So here we'll select application mode again, match on Facebook traffic. Again, select a predefined policy, and in this case, choose best effort since it's low priority data. Its preferred path will be over the internet circuit. If the internet circuit is down, it will black hole the traffic since it is not business critical. So once we save that configuration policy, the next step is to apply it to the Hubmaster controller. So here we go to the node view. Via the drop-down, we select Hubmaster controller. Here we have our node, the Hubmaster controller. And again, we can move to the Actions tab to select this node and start provisioning. Now we can see the provisioning is complete on the Hubmaster controller. If we use the grid view, we can see that the features have been configured and the state is now in a provisioned state, meaning all of the feature set configured in Gluware is applied to the Hubmaster controller. For a manual verification, we can connect to the node and via CLI execute a command to look at the master policy. So here in the policy, we can see that there is an existing classes for voice and video are already there, and we can see that the new classes for Office 365 and Facebook have been applied to the node. In this proof of concept, we showed how in our current landscape, the orchestration layer can talk directly to the network layer to configure the application path to the data center. Taking a look at this working group's desired architectural framework, there's a need for open APIs and programmable interfaces between controllers and orchestrators and between controllers and the infrastructure layer elements. This would allow WAN orchestration to easily communicate to the other orchestrators as well as the various SDN controllers as they evolve for each infrastructure domain. Thank you for your time and attention today. For more information on the workgroup, please visit opennetworkingusergroup.com. For more information on Glue Networks, please visit gluenetworks.com or follow us on Twitter @GlueNetworks.